Okay, hi everyone. Apologies that I'm still not there today. We're going to look at the next two sections of the chapter today, and I've made you a video on each to run through the notes as I would do in the lesson, and then you'll be working on exercise 8b and 8c as well. So the next part of the chapter that we need to cover is dummy activities. So I'll try and explain a bit with an example about why we need these. So if I look at this precedence table that I've got over here, which is what you would have looked at last lesson, let's try and draw this as an activity network. So if we start off with the source at 0, and I can see that activity A is going to be first because it has no dependencies. Then activity B is dependent on activity A, so that's going to come next. Activity C is dependent on activity B. So we can draw that one in, draw C coming off of B. Now here we hit a problem because activity D is also dependent on activity B. Now you might be tempted to do this. I don't know, draw another line coming out of the event that B is complete and call that D. And have that going into our final activity, which is E, which is dependent on both C and D. However, this is not how these activity networks can be drawn. So in an activity network, in order to use these sort of later in the chapter for the things that they're going to be useful for, we can't have two activities sprouting from the same event. So it says here, it might be tempting to use two curved edges between nodes 2 and 3, but every activity must be uniquely represented in terms of its events, meaning that there can be at most one activity between events. So that means at least one arc between two nodes. We can't have two arcs between two nodes. So we can't do this. This is bad. And this is where dummy activities come in. This is where why they become useful, because they allow us to draw the activity networks in the way that's going to be useful for solving problems later. Now, a dummy activity is shown by a dotted line, shown with a dotted line on the diagram. It has no time or cost. It just shows the dependencies in the way that we need to show them for this chapter. So I'll show you how we should draw this activity network with dummy activities. So if I start again here with the source at 0, and of course A is going to be coming off of that. B comes next. There weren't any issues at this stage. Okay, and then once B is complete, I'm going to draw C coming off of B, and I'm going to draw D coming off of the same event that B is complete, but you see they're going in different directions. They're not going to meet at the same node because it's not allowed in how this sort of works. So say I've completed C and D, I need somehow to show that E is coming off these two events being completed because E is dependent on C and D. So if I draw E over here coming off of C, and if I draw my dotted line, my dummy activity over here, and I don't label it, I just leave it as a dotted line, this shows the dependency of E on both C and D. So it's saying that D also needs to be complete as well as C. Those things meet at 3 in order for E to be completed. So this is one way of drawing with dummy activities that would work, because you can see we don't then have the issue of the activities not being uniquely represented and there being just one activity between each of the events, each of the nodes. We could draw this in a different way, of course, and there's often more than one way we can draw the dummy activities in. It's not always just one right answer. So just to show you another way, we'd start off with our A and B as before, and C and D are going to be coming off of the completion of activity B as before, but we could also draw them like this, with the dummy activity now flowing from C to D, and then E flowing out of the completion of activity D. Yeah, like this. So it doesn't really matter which way you draw the dotted line, as long as it feeds into the event that precedes E, in both cases it does, then we've got a diagram that's going to work for us. Okay, let's look at a couple more examples to help you get the hang of this. Right, so draw an activity network for this precedence table, use exactly 2 dummies. So let's start. If you want to have a go, just pause the video, don't feel like you need to follow along, have a go, and then you can always check your answer afterwards. So we've got the source at 0, A is going to be first because it has no dependencies. And then we can see that B, C and D are all dependent on A. So once I've completed A, I can do these 3 activities. I can do B, C and D. Okay, the next activity I can complete is E, and that comes after B is completed. So let's complete B and show E coming off of that one. Okay, and next it's going to be F. Now F is dependent on both B and C. So F is dependent on both B and C. So that's going to be tricky. I could draw it coming off of B. I think what I'm going to do is draw it coming off of C. So if I complete C over here and I draw F coming off there, I just need to show, because it's also dependent on B, I just need to show that dependency, and that's going to be my first dummy activity. So yeah, so this therefore shows that F is going to be dependent on both B and C, but keeping the rules of how the diagrams are drawn at the same time. Okay, so we've got down to, just tick these off so we can see where we've got to. Right, we've got up to G, and G is dependent on both D and F. So there are a couple of ways I could draw this. I could show G coming off of activity D. So I could do this. And I could show F being completed and that flowing kind of backwards into that 4th event there, to show that in order to complete G, we've got this dependency on F as well as on D. There's one way of drawing it that would be perfectly correct and fine. I'll just show you another way as well. So I could alternatively show it flowing from D, or no, sorry, we did that before, didn't we? Show it flowing from F. So say I do this. So G is dependent on F, but it's also dependent on D. So I can show the dummy activity coming in this direction from the node that represents the completion of D into the node that represents the completion of F, and out of that we're having our activity G. So however you want to draw it, that's okay. I drew it like this initially, so I'm going to stick with this. Then we've got H. H is dependent on D. So yeah, we can draw, let's just draw it like this for now. And I is dependent on G and H. So I'm just going to have to redraw this a little bit, because I'm going to have I that is dependent on G and H. Okay, so say we've completed G, then as long as I've completed H as well, so if I draw this H, I just change that so it's feeding into this node over here, and now coming out of this one I can say I've got I. I'm gonna draw it up in this direction. Explain why in a second. I've completed my diagram almost, apart from I need to have the sync, so the bit at the end where all the final activities join up to show that the process is complete. And I'm just going to elongate E to meet I, activity I. And they're going to meet there and the process will be complete. Okay, one more example, I think. Whoops, one more example.